Water is life. We use it for many things, including keeping ourselves and our environment clean. It washes away dirt and waste and conveniently disappears down the drain, taking our filth with it. But where does that dirty, contaminated water go? Once wastewater disappears down the drain, it flows to the city's underground wastewater pipes, which deliver it to one of the city's 3 wastewater treatment plants. The city of Rio Rancho has 402 miles of sanitary sewer lines and 27 lift stations. These lift stations are located throughout the city to help areas where wastewater cannot easily flow through by gravity and needs to be lifted from a lower elevation to a higher elevation. Finally, the untreated water or influent reaches its destination, the wastewater treatment plant. Once wastewater arrives at the treatment plant, the first place it goes is through the bar screen, a large metal grate used to remove large inorganic solids from the waste stream. The bar screen stops the large solid pieces of waste from moving forward, things like toilet and tissue paper, cardboard, wipes, and paper and plastics that should never have been put down the sink or toilet in the first place. These materials are collected on a conveyor belt and dropped into a large bin to be taken to the landfill where they belong. The rest of the wastewater moves through the bar screen and on to the next step, where the magic happens. At this point, even though the large waste has been removed, the wastewater is still filled with dirt, grease, soap, and many other contaminants from homes and businesses. How is all that gunk removed? A wastewater treatment plant is basically a bug factory where microorganisms are grown. These living creatures include microscopic plants and animals such as bacteria, molds, protozoa, algae, and small metazoa. They clean the water by breaking down organic matter, removing pollution, and producing clean water. These good bugs are the actual workhorses of the wastewater treatment system. Smaller than what the human eye can see, these microbes, or bugs, are carefully controlled by the treatment plant staff to work their magic and clean the water. This guy is called a tardigrade, or water bear, seen under the microscope hard at work cleaning the water by digesting contaminants. After the bar screen, the wastewater flows through a series of tanks, first entering the anoxic tank. The anoxic tank creates an environment for the waste to be deprived of oxygen to reduce the amount of nitrogen present in the waste. When the bacteria are in that state of deprivation, they rely on the nitrates for oxygen to break down the waste. What does that mean? We are starving the good bacteria in the waste by providing a limited amount of air bubbles or oxygen. So when it is processed to the next tank, which is the aeration basin, the good bacteria are hungry and ready to break down the waste. The aeration tanks are chambers for injecting air into water. Compressed air bubbles are put through the watery waste in the aeration tanks to provide oxygen. This activates the good bacteria and makes them grow rapidly so they can break down the waste in the aeration tank. Once the contaminants and pollution have been digested by the good bugs, what's left are water, heavier solid particles that remain after the good bacteria have done their work, and floatable scum that is not heavy enough to settle. This mixture flows into a clarifier, a large cone-shaped settling tank used to separate solid and liquid material. The lighter scum floats to the top of the clarifier, where large skimmers push it into a container and remove it. Gravity causes the heavier suspended solids to settle in the bottom of the clarifier as sludge, sometimes called biosolids. Scrapers at the bottom of the clarifier remove the sludge by directing them to a pipe. The sludge and scum are sent to the belt press for a chemical treatment called coagulation flocculation. The addition of a chemical causes the solids to bond together and allows the belt press to squeeze the water from the solids, which is called dewatering. Once the solids have gone through the dewatering process, the solids are disposed of in a large garbage truck. Then it's on to the landfill. The remaining water from the clarifier is called effluent, which is now ready for one last step. Samples of the effluent are taken and sent to the on-site lab, where once again the water is checked for bugs. There should only be good bugs left, but their work is done, and before the water can be returned to the river, the good bugs must be removed. The final step before the effluent returns to the river is ultraviolet disinfection, or UV. The effluent passes through ultraviolet light to kill any leftover bacteria and other microorganisms in the water. Once the UV system has done its job, the clean, disinfected water is sent to its final destination, the Rio Grande. Here we see the outfall or exit point into the Rio Grande. Usually a pipe or pipes, the outfall is where effluent is discharged from the wastewater treatment system into the receiving water. Outfalls are engineered to make sure the effluent mixes properly with the receiving waters. Reusable wastewater, called reclaimed water, is a great way to ensure we don't waste the precious resource of water. Instead, with the help of science, technology, and some really good bugs, we are able to reuse a precious resource and return it to the environment as a home for our richly diverse bosky wildlife.